Right. So as we discussed the previous topics, intensive property and extensive properties. What is the intensive property means? Whatever is the property which is independent on weight of the substance present in the system. Extensive properties means which are dependent on weight of the substance present in the system. Right. So there are various properties will be there. Independent properties means what? Pressure and temperature, which are independent on weight, right? So dependent properties means mass and volume, even some other properties we have discussed, right? So density is intensive or extensive? Intensive property. So just we have to remember that. So the ratio of extensive properties ratio becomes intensive property, right? And coming to the part of state functions and path functions, so when a system A is converted to B in many pathways, what are the initial states of the system and what are the final states of the system? And these are pathways 1, 2, 3, like so on, right? So these are pathways. Whatever is the property that is depends on initial and final states of the system and independent on pathways, that is known as state function. All the thermodynamic functions or properties are known as state functions, right? So then path functions means which are depends on only pathways. Only two functions are there. One is heat, then other one is work. So these two are path functions. The relation between state functions and path functions we are going to discuss in thermodynamics, right? And also here continuation of this, state functions are exact differentials and path functions are inexact differentials, right? So write the statement. State functions are exact differentials and path functions are inexact differentials. Path functions are inexact differentials. What is meant by exact differentials and inexact differentials, right? See, when we have discussed whether the properties depends on pathway or independent on pathway, based on that we are able to get the values with the help of integral values. So that is also we have discussed in the previous class, right? What is meant by exact differentials and inexact differentials, right? So we'll see. State functions are what? All thermodynamic properties, right? What are the thermodynamic properties? Entropy, internal energy, enthalpy, Gibbs free energy and Helmholtz energy function. These all are thermodynamic properties. All thermodynamic properties are exact differentials. All thermodynamic properties are exact differentials, right? So because these all are acts as state functions, right? So just we go with simple equations, that is a Euler's formula. What is meant by exact differentials we have to see, right? So if the function z is equals to m dx plus n dy, the function which will be in the form of m dx plus n dy, right? So some term into dx plus some term into dy. So z is equals to m dx plus n dy. If you differentiate this, means d of z is equals to, right? So this is the m is the function is depends on x comma y into dx plus even the n is also function of x comma y into dy. How we are going to say this is the function z is a exact differential or not, right? So therefore we have to say m is depends on x and y. So therefore dou m by dou x at y is equals to dou n by dou y at x. So this must be equal, right? So m is a function of x and y, right? M is a function of x and y. This m will be differentiating with respect to x at constant y. So then n is also as a function of x and y. n is differentiating with respect to y at x. So when these two are equal, therefore we have to say that particular property is a exact differential property. So that exact differential property is nothing but state function. Nothing but state function, right? So this is the formula we have to apply, right? So whether these are satisfying these thermodynamic properties or not, we have to check once, right? So we have to consider one equation, right? We'll verify that s is as function of so just ds is equals to dq by t, tds is equals to dE plus p dv, e and v. Okay, right. So therefore s is as function of e comma v. S is as function of E comma V. E means internal energy, V for volume, right? So whenever two functions are there, we have to apply the differentiation. So that what is the differentiation of this ds means ds is equals to right, f of E means that is differentiation of S with respect to E at constant volume, right? So into dE plus differentiation of S with respect to volume at constant E into dV, right? So these formulas we have discussed already in basic concepts, right? So whenever a function of u and v will be there, right? So z is as function of x comma y. So therefore dz is equals to, we wrote that, so dou z by dou x at y into dx plus dou z by dou y into at x into dy, right? So as like that, so this will be, we have to write, right? So that is in terms of what, dE and dV, right? So but s is a function of, s is equals to means ds is equals to dq by t. Therefore t ds is equals to, these equations we will get later, right? So while we are explaining about the definition of entropy, at the time we will get all those things. Just how it is exact differential or not, just we are going to verify, right? So tds is equals to dq from first law of thermodynamics, dE plus p dv. So which is equals to tds is equals to, so therefore ds is equals to dE plus p dv by t, right? So this dE term and dE term we have to compare. So this dou s by dou E at v is equals to 1 by t into dE, right? So this we have to written as 1 by t into dE plus p by t into dv, right? So we have to compare these dE and dV terms, Here what is the dE term? Dou s by dou E at v is equals to 1 by t. Here dE term is 1 by t. Here dV term is what? Dou s by dou v at E is equals to p by t, right? So now what is the constant? We have to differentiate with respect to that. Whatever is the constant, we have to differentiate with respect to that, right? So therefore dou by dou v of dou s by dou E is equals to dou by dou v of 1 by t. Whenever we are going to differentiate with respect to volume, this t is constant or not? Only temperature term is there here. Temperature is constant. We are differentiating with respect to volume only. If any volume term will be there, that can differentiate. But there is no volume term. Therefore, this is a constant. Constant differentiation is what? 0. Right? So, similarly, here dou by dou E means what is the constant here? E. Differentiating with respect to this, dou S by dou V is equals to dou by dou E of P by T. Here differentiating with respect to internal energy. Is there any internal energy terms? No. Therefore this becomes constant. Therefore this is also becomes equals 0. Hence we have to written as, so these two will be equal. That is here I am writing dou 2s by dou e dou v is equals to dou 2s by dou v dou e. So therefore hence the entropy is a exact differential. That means how many terms here we have? E and V. First we are doing differentiation with respect to E, and later on V. What we are getting the result. So once that entropy is differentiating first with respect to volume, then after that internal energy, we able to get same value. So therefore we have to say entropy is a exact differential. Therefore entropy is a state function. All the state functions are what? Exact differentials, right? If we consider path function, heat and work, so we won't get this equations, right? This is the equation is known as what? Euler's equation, right? So no need to by heart this, because we will get this terminology again in next classes. Just what is you have to remember and understand that. So the exact differential means by doing differentiation two functions will be there. So first entropy will be differentiated with respect to E, and after that differentiate with respect to V, we will get some result. Now reverse, entropy differentiate with respect to V, and later on differentiate with respect to E. In both the cases we are getting the same result, right? So as we discussed in the previous with the help of integration also, initial states and final states, if we can change the pathways, these functions are independent on pathways, we will get the same result only, right? Even that is also concluded that, so these state functions are exact differentials, right? So therefore here you made a statement, entropy is a exact differential, right? Hence entropy is a exact differential, because the right hand side values are 0 only in both the cases. Therefore LHS will be same. What is LHS means? Here just you have to observe, differentiating entropy with respect to internal energy first, later on volume. Here differentiating entropy first with respect to volume, later on internal energy. While we are doing, whenever the function is depends on two properties, right? So whatever it you have to utilize, the overall result will be same. So therefore we have to say that function is becomes an exact differential, right? So this is concept is applicable for the state functions and path functions. Path functions are what? Inexact differentials. What is meant by inexact differentials? We able to get unequal values during that differentiation, right? So this is the formula. This is the formula is Euler's formula or Euler's rule, right? Just mention there. Here also same thing only. M is depends on what? X and Y. Differentiating with respect to X at constant Y. So here differentiating with respect to Y at constant X. So both are giving same. Therefore, so that becomes exact differentials. Okay. Euler's rule or Euler's formula. So this is our state functions and path functions, right? So because whatever is the concept we have to understand, our thermodynamics is what? First thing is whether the reaction is feasible or not. If that reaction is feasible, whether it is a spontaneous or not, that is our aim to discuss. So for that only we have to understand all those things, right? With the help of these terminologies we are able to get so such results, and we have to apply for various reactions, right? So some other terminology will be there, so that we have to discuss. It is completed? No? Okay. Right. What are the path functions? Work and heat, right? So we'll go with path functions, right? Heat is denoted with Q. Put heading heat. So what is meant by heat? Heat means a form of energy that is due to temperature difference, right? Right. So write down. Right. Right. Heat means Q. Write down. It is a disordered form of energy. It is a disordered form of energy. Disordered means heat is temperature difference is there, means randomly it will be transfer between the system and surroundings, right? And it is a disordered form of energy and it is exchanged between system and surroundings due to temperature difference. What is meant by heat? Heat is a disordered form of energy. There is no particular order, right? If you take some hot water, kept it on the bench, so that will be transferred to the environment. There is no proper order to transfer of that heat to the environment. Randomly in 360 degrees it may be distributes, right, into the surroundings, right? So that's why it is a disordered form of energy and it is exchanged between system and surroundings due to temperature difference. That is called heat, right? So what are the units of heat? Units of heat. It is a what form of energy? What are the energy units? Calories, joules, ergs, kilocalories, kilojoules, etc. These all are units of heat. Calories, joules, ergs, kilocalories or kilojoules, etc. Right. So what is meant by here the terminology, right? The heat arises due to the temperature difference. The temperature difference between the what? System and surroundings. If temperature difference will be there, what will happen we'll see, right? The first one, if temperature of the system is greater than temperature of the surroundings, whose temperature will be more? System. Therefore the heat is transferred from system to surroundings. Whenever some amount of heat is transferred, the system is gaining energy or losing energy? Losing energy. Some of the energy is transferred from system to surroundings because system is at a higher temperature, right? Therefore heat is evolved. In this case what? Heat is evolved. When heat is evolved, right, what about Q? That becomes negative. When system temperature will be more, at the time some amount of heat is transferred from system to surroundings, right? So therefore at that time Q is equals to what? Negative, right? Heat is evolved, right? So second situation, if when heat is evolved by the system or surroundings? Heat is evolved by the system. So because system temperature will be more, right? Terminology is very important. System temperature will be more. So if we consider a simple diagram, this is the system will be there. So this is high temperature and the surroundings will be low temperature, right? So whenever it will be transferred, right? So the difference will be surroundings minus system, that becomes what? This is the higher temperature means lower minus higher, that becomes negative, right? So some of the amount of heat is lost by the system, therefore that is what? Negative, right? Heat is evolved, right? If system temperature is less than of surroundings temperature, right, heat is evolved by the system. Here you have to mention heat is evolved by the system, therefore Q is negative. Here surroundings temperature will be more, therefore system is gaining heat energy. System is gaining heat energy, therefore heat is, in this case, heat is observed by the system. When heat is observed by the system, what about Q? Positive, right? Some heat is observed by the system, therefore heat Q is equals to what? Positive. Heat is evolved by the system. Heat is evolved by the system. At that time Q is negative, right? So this is, heat is a form of energy, disordered form of energy, and that is exchanged between the system and surroundings due to what? Temperature difference. If temperature of system will be more, at that time heat is evolved by the system. If the temperature of surroundings will be more, heat is observed by the system, right? So in third case will be there, when temperature of the system is equal to the temperature of the surroundings, right? So what about the third case is temperature of system, if temperature of system is equals to temperature of surroundings, so therefore what will happen? Temperature is constant, right? So therefore that reaction is said to be equilibrium. Whenever the both system temperature and surroundings temperature will be same, therefore that is the system is said to be what? In equilibrium with respect to temperature, therefore that is called what? Thermal equilibrium. We have discussed that in importance of thermodynamics, the attainment of equilibrium also can be explained with the help of thermodynamics, right? So this is the reason the temperature of the system and surroundings will be constant, right? Therefore at the time, so the system and surroundings are present in equilibrium, particularly in thermal equilibrium. This is the terminology we have to utilize in zeroth law of thermodynamics, right? So whatever is the system we have to consider, that will be thermally equilibrium with the other system, means both the systems and other system or system and surroundings temperatures will be same only, right? So whenever the temperatures are same, it is said to be in equilibrium, right? If system temperature will be more, heat is evolved by the system, at the time Q is negative. If temperature of surroundings will be more, heat is observed by the system, at the time Q is positive, right? Whenever both the temperatures are same, therefore that is said to be in thermal equilibrium, right? So this is about heat, right? So similarly, which is correlated with work factor, right? So then putting work, terminology is very important because we have to utilize the terminology only, right? So we have to use many cases just, so what is the heat, whether it is a heat energy or it is a work energy, right? So we said that in importance, heat energy is transferred or converted into various form of other energies, right? So how the energy is exchanged between heat and other form of energies, so that we are going to verify, right? So this is the heat and what is the work, right? Work is denoted with W, right? Write down. It is a ordered form of energy. It is a ordered form of energy. It is a ordered form of energy and it is exchanged between is exchanged between system and surroundings. It is exchanged between system and surroundings other than temperature difference. What is meant by heat? Heat is due to temperature difference, right? Other than the temperature, remaining all will be considered as what? Work. So work is a ordered form of energy. Work is a what? Ordered form of energy. So then heat is a what? Disordered form of energy. Ordered and disordered, we have to remember, right? So therefore it is other than the temperature difference, means which one is difference is there? Pressure difference is there. Therefore we will get pressure difference, right? Means work energy is obtained. Work is the ordered form of energy which is obtained due to pressure difference between the system and surroundings, right? If temperature difference is there, that is called heat. If pressure difference is there, that is called work, right? So this is the heat and work definitions, right? What are the units of work? Same units, because it is also what? Energy, right? It is a form of energy. Energy units are what? Calories, joules, airs, kilocalories and kilojoules, right? So but it will be with respect to pressure difference, some more units we have to add, right? In addition to that, so the units will be liter, atmosphere also we have to add. Work is the what? Liter, atmosphere. These are the liter, ATM also units for work. In addition to all, right? Even remaining work will be is the form of energy that will be expressed in calories and joules, then kilocalories and kilojoules, etc. Right? Right. You may try to understand the language, right? So because terminology is most important. So as similar to the temperature, even pressure differences will be there, right? So one pressure difference is, the first one will be pressure of system is greater than pressure of surroundings. If pressure of system is greater than pressure of surroundings, right, which will done work? System will done work or surroundings? Whose pressure will be more? System pressure will be more. So therefore the pressure will be transferred from system to surroundings. So who is doing work? System is doing work, right? So therefore when pressure of the system will be more, right? So the pressure of the system will be more compared to surroundings. So there work done by the system, work done by the system on what? Surroundings. Work done by the system on surroundings, right? Whenever the system is going to do some work, is it losing energy or gaining energy? Going to do work. Without breakfast, lunch, dinner, you have worked for an entire day. At that time you are gaining energy. By doing work, losing energy, right? So therefore, what about the work notation? W is equals to negative, right? So here system pressure will be more. Some pressure will be transferred from system to surroundings, right? So means the system is going to do work. So when system is going to do work means work done by the system on surroundings. So therefore at that time work W is equals to what? Negative, right? So next, second case, if pressure of system is less than of pressure of surroundings, surroundings pressure will be more. Therefore, so work will be done on the system by surroundings, right? So therefore we are able to write work done on the system, work done on the system by surroundings. Work done on the system by surroundings. Whenever work done on the system means system is gaining or losing. Here surroundings pressure will be more. Some pressure will be transferred to system. At the time system is gaining. So when system is gaining, therefore W is equals to what? Positive. Right? W is equals to positive. So what about the third condition? If pressure of system is equals to pressure of surroundings. Whenever temperature will be same, what is meant by process? That process is present in thermal equilibrium. If pressures are same, what is that? Pressure of the system is equal to pressure of the surroundings. Therefore the system and surroundings are present in mechanical equilibrium. Mechanical equilibrium. We have to remember mechanical equilibrium means the pressures always constant. Thermal equilibrium means temperatures are constant. Whether that may be considered for one system to other system or system to surroundings, whatever it. If you have two systems, both the systems are having same temperature means those systems are present in thermal equilibrium. If the pressure of both the systems are equal means both the systems are present in mechanical equilibrium, right? So the pressure will be indicates work, right? Temperature will be give heat energy. So heat is a disordered form of energy and work is a ordered form of energy, right? So what is meant by mechanical work, that we have to discuss. So before that I want to give some note, right? So tell me you people, right? Note. First one, heat is transferred to work. Second one, work is transferred to heat. Which one is possible and why? Only one is possible, or two is possible, or both are possible? Then why? Heat is converted to work or not? Heat is converted to work or not? Yes, heat is converted to work. Some work is converted to heat or not? Yes, work also converted to heat. Both are possible. Work is converted to heat and heat is converted to work. Is it clear? Or shall I give example? Heat is converted to work, right? So heat energy we have to utilize to get some result, output, right? So burning of fuel. Burning of fuel means which involved in combustion process. Combustion process means heat is evolved, right? That heat we have to utilize to run the vehicle to move from one place to another place. That is called work. Displacement of an object from one place to another place by the application of external force is called work only, right? So therefore heat is converted to work. Work is also converted into heat. Both are possible, right? Now the 100% heat is converted to work or 100% work is converted to heat. Which one is correct and why? Previously we didn't mention entire heat is converted to work or not. Heat is converted to work only, but the complete heat cannot be converted into work. Only few amount of heat is converted into work, but the complete work is converted into heat, right? So therefore 100% work is converted into heat, but 100% heat is cannot be converted into work, right? So that can be explained with the help of second law of thermodynamics, right? So this is a terminology we have to explain with the help of second law of thermodynamics. Remember this. At that time again I will ask this question, right? Because here heat is there, work is there. So what was the relation between them? That should be mentioned in the note, right? Just you have to remember this. Without 100% means it will be possible. Both are possible. Some heat will be converted to work, some work will be converted to heat. Whenever we are going to complete work is converted into heat, but complete heat cannot be converted into work. The simple example, right? So you charge your mobile, morning 100% will be there. So at the time of evening, so for example 30% is there. How much? 70%. Is that complete 70% you only used? Even in rest mode also it will be utilizes. You didn't use 70%. So right, background works is going on, so that should be wasted only. How much you have to utilize? Only few only you have to utilize. Isn't it or not? 70%. The battery 100%, complete 100% you have to utilize in mobile. So whether you forget about your daily habituals, simply you focus on complete mobile, then you have to get. So but whenever you may spend that time means that becomes causes very numerous problems, right? So that is heat is cannot be converted into work 100% because some amount of heat is wasted. Some amount of heat is wasted, simply entered into the environment only, right? That we cannot get it back, right? So only few amount of heat can be utilized to do work that can give the efficiency, right? So if 100% efficiency will be there, we no need to purchase the mobile again and again. Once you purchase, that will be helpful for your lifetime, right? But we are purchasing within 2 years, within 3 years again and again, because the efficiency of mobile will be what? Only 2 to 3 years only. Whatever is the brand you may utilize. So up to 3 to 4 years maximum, right? So then we have to change. Means that is the efficiency only. If 100% efficiency is there, so that can be utilized for a lifetime also, right? No electronic gadgets we cannot use for a lifetime. So only certain period will be there. For example, even bikes also. What is the lifespan of bike? Only 15 years, right? If we may maintain properly, so that will be extendable some more 5 years only. But not our entire life period we have to use only one bike. No, that is not possible. So means the heat cannot be converted into work continuously. Little bit will be wasted, will be there. Any heat engine we have to consider some amount of heat will be transferred to the environment, so that we cannot get it back. Therefore only few amount of heat is converted into work. Therefore this is a statement is wrong. That can be proved by Carnot in its Carnot theory. So that is in case of second law of thermodynamics. Okay, right. What is the definition of work? Work definition. So this is also definition only, but some equations, mechanical work we have to discuss, right? So the displacement of an object, write down. The displacement of, I'll spend much time here because we have to know the work and heat only. So because in many cases simply we called as work done by the system, work done on the system, right? So then heat is observed, heat is evolved. All the notations we have to capture in our mind, right? With the help of all these things, right? The displacement of an object by the application of external pressure, by the application of external pressure called work, particularly that is what? Mechanical work. MW means what? Mechanical work, right? Any object displacement, right? See, see, I have done some work. What I have done? So some displacement of chair with the help of my hand, right? So force is applied on that object to displace from one place to another place. That is called work only, right? So chair is here, I am applying some force and adjusted to here. So that is called work only. So work, that is small work or big work, whatever it, that should be work. Displacement of an object by the application of external force is called work. So therefore W is equals to, we have to written as F into displacement, force into displacement. F for what? Force, displacement, force into displacement, right? So then we have to utilize this equation, right? force into displacement. So that will be W will be F, force will be divided with area and multiplied with area, and displacement will be there. By dividing and multiplying, is there change in their value? A get cancelled. What we are getting? F into dl. F into dl is called what? Work. Right? So by dividing and multiplying, there is no change of that particular value. Right? So that's why divided with area and multiplied with area. Area into length. What about this? Area into length. Volume. Small length will be there. That's why small volume will get. Right? So then what is meant by F by A? What? Pressure. Now tell me the definition of pressure. Therefore W is equals to P dV. What is meant by pressure? Force per unit area. Already we discussed that pressure in the first, it seems first class only, introduction class. Right? So force per unit area, that is called pressure. Right? So therefore this is the pressure is equals to force per unit area, where area is equals to 1 centimeter square or 1 meter square. Right? The corresponding force will be equals to what? Pressure. Right? So when A is 1, this is the A is the 1 means F is equals to what? F is force is equals to pressure only. Right? So the force per unit area is 1 centimeter square or 1 meter square. The corresponding force will be equals to pressure. Therefore W is equals to what? P dV. Right? Next. If the pressure is opposing force, or external pressure, if that pressure is what? The force is what? Opposing force, and also pressure also what? External pressure. So therefore, so this is the pressure, and opposing pressure means its notation will be, sign will be negative. Therefore W is equals to minus P external into dV. Therefore W is equals to what? Minus P dV. W is equals to minus P dV. Right? W is equals to minus P dV. Minus P, when we have to write external pressure, we have to utilize. Right? External means surroundings. If system pressure we have to utilize, what is W? P dV. Right? So P dV and minus P dV, the sign will be difference. That is opposing force or external pressure we have to utilize. So therefore that we will get W is equals to minus P dV. Right? W is equals to minus P dV. So this is the mechanical work. Right? W is equals to minus P dV. Right? So we'll see. For free expansion, for free expansion means, what about the external pressure? Some gas is there. Right? So free expansion means internal pressure is there, that is the pressure of the gas. P external is there. Whenever this piston will move up, this P external becomes 0. External pressure becomes 0 means which will be freely moved. That is the expansion process. Right? So when free expansion is carried out means its external pressure will be 0. Right? So for free expansion, P external is equal 0. Therefore at that time, what is the work? W also 0, because W is equals to what? P dV. P external into dV. Right? So that W is equals to P external into dV. Right? That becomes 0. Right? Next one. If the process is, if the work done is carried out in closed vessel. If the work done is carried out in closed vessel, right? In closed vessel work done is carried out. What about in closed container? Is there change in volume? Volume will be changed in the closed container? No, that change in volume will be fixed. Therefore dV will be what? 0. No change of volume in a closed vessel. So whatever is a container, 1 liter bottle we have to consider. So whatever is the gas will be present in that bottle, so that cannot be changed. The volume of that gas cannot be changed in a closed vessel. So therefore in a closed vessel, so there is no change of volume. Therefore dV is equals to 0. Therefore what about W? W is equals to minus PdV. Therefore at that time also 0. No work done in closed vessel, and also no work done during free expansion. Even this is expansion of gas in vacuum also. Expansion of gas in vacuum. Expansion of gas in vacuum or free expansion, at that time work done will be 0. All this terminology, right, important. Even we able to get the direct 2 marks question from this only, right? So that is the already covered in the previous examinations, right? So these all will be covered in the previous examinations. For free expansion, what is the work done? Therefore W is positive, W is negative, W is 0 or none of the above, right? So for free expansion, what about W? Not only W, even this will be related with other parameters also, right? Like internal energy, work done, right, heat energy, and all those things will be there, right? Okay. So this is the 2 cases. One is the free expansion and work done is carried out in a closed vessel, right? So right. So when work done by the system, right? So the next terminologies will be work done by the system. What about this process, work done by the system? Expansion process is compression process. Work done by the system, right? System is going to do work, means some expansion will be takes place. So simply we'll take system with the surroundings, right? This is the system, this is the surroundings, right? So whenever work done by the system means system is going to do, system force will be more, means the piston will move up. Therefore which process will get? Expansion process. Expansion process. For expansion process, what about the volume? dV is, volume is increasing or decreasing? Decreasing. Therefore dV or delta V, change in volume, is positive or negative? Volume is increasing. Initially V1 is there, initially V1, now V2. Volume is increasing. V2 minus V1 is positive or negative? Positive. Whenever dV is positive, therefore W is equals to what? Minus P into dV. This is the positive, means positive into negative means that is negative. For expansion process, what about the work? Negative. For expansion process, right? So work done by the system means expansion process is carried out. So for expansion process, what about W? What about W? Negative, right? Expansion means system is only going to do work. Whenever system is going to do work, it's lose some amount of energy. Therefore that is the expressed in negative, right? So next, work done on the system. Work done on the system, right? Work done on the system. So what about work done on the system? What about that process? Compression process, right? If we consider the system, right? So this is the system, this is the surroundings. Work done on the system means external force will be very high, therefore the piston will be moved down, right? This time volume is decreasing or increasing? Decreasing, right? So lower volume minus higher volume. What about the volume? Change in volume is what? For compression process, dV or delta V is equals to negative. Volume is negative. Previously 10 liters will be there. Now 8 liters. 8 minus 10. How much? 8 minus 10. Minus 2 liters. That is the change in volume is what? Minus. This will be substituted in W. Therefore W is equals to what? Minus P into dV. dV is negative means what about overall W? That becomes positive. For compression process, what about the work? Positive. Simple when the compression process is carried out, work done on the system. At that time system is gaining some amount of energy. While system is gaining means the obtained work will be positive. Work done by the system is going to do work. At that time W is equals to negative. Right? Definition, terminology, each and every point is important. If you want to understand the further topic, each and every terminology is important. Right? So I think you are getting little bit bored because some continuous terminology we are getting. Just you have to focus and you have to interfere into that, right? So just you have to involve. So then you will get, right? Work done. I am the system. I am doing work. I am taking the lecture. So I want to lose some amount of energy, right? At the time the work will be expressed with a negative sign, right? If simply you people are sitting there only, you are not doing anything, you are not writing, just simply sitting, right? While I am explaining, you people want to observe the some concept, right? You are gaining. Therefore, at that time, you are doing work, but positive sign will be there, right? Like that. So the work is positive, work is negative, and when Q is negative means heat is observed. Heat is Q is negative. Q is positive with respect to system and with respect to surrounding. Both we have to say, right? You are getting confusion. So once again we'll see, right? Even we have to express, but most of the cases system can be used as a reference one rather than surroundings, right? When Q is, if heat is observed, write down, if heat is observed, what about Q? Positive. Who is observing? System is observing. Heat is observed means who is observing? System, right? So system is observing. If heat is observed, that is Q is positive. If heat is evolved, if heat is evolved, what about Q? That is negative. Okay. Clear? It is observed, heat is released. What is meant by work done? What is meant by work done by the system on the surroundings? What is meant by work done on the system by the surroundings? What are the notations of work done? What is the expansion process? What is the compression process? What is the free expansion? What is the expansion of gas in vacuum, right? So then all those things will be discussed, right? Only terminology can be utilized. With the help of the terminology, we are able to give the notations of work. W is equals to what? Minus PdV. W is equals to minus PdV. So this is about what? Heat and work. So even I have taken in detailed picture about heat and work. You don't confuse. After the class, you may sit at home and just you have to think what is the heat. Heat is due to temperature difference. When temperature will be same, right? Room temperature, atmosphere temperature, both are same. Therefore, so room and environment will be present in thermal equilibrium. Temperature will be same, right? So that is heat only, right? So then pressure will be same. That is mechanical equilibrium. So when we are going to discuss about the pressure means that is the work, right? So other than the temperature, that is called work. Due to temperature, that is called heat. 100% heat cannot be converted into work, but 100% work is converted into heat energy, right? So those terminology, and for expansion and compression, so all those things we have to remember, right? So next move on to internal energy. Just move on to internal energy. This is denoted with E or U. Any one notation we have to utilize, either E or U. U is called internal energy or E is also called internal energy, right? What is meant by internal energy? Internal energy. Can you run 100 kilometers without stopping? No. You can run up to 5 kilometers. That is your internal energy. With the help of internal energy, someone can run 1 kilometer only, someone can run 5 kilometers, someone can run 10 kilometers. Right? So whatever is the energy, it will be present in the system. Right? So how many parameters are there? So that is right. Write down the sum of various energies, the sum of various energies present in the system. The sum of various energies present in the system called internal energy, right? So this is called what? Internal energy, right? So it is denoted with E or U, right? Symbol will be or denoted with E or U, right? That is internal energy E or U is equals to potential energy plus kinetic energy, right? Potential energy and kinetic energy, right? So what are the how many type of kinetic energies? Kinetic energies will be translational energy, rotational energy, vibrational energy, electronic energy. The sum of all energies, the sum of this all potential energy and as well as kinetic energy, that will be equals to what? Internal energy. Whatever is the system is carrying potential energy and kinetic energy, so that will be called as internal energy, right? So that is one definition. Even one more definition also there, right? The energy of the system at constant volume. Energy of the system at constant volume. That is also called what? Internal energy. Whatever is the system, we may consider its system energy will be there, that we have to consider at a constant volume. So constant volume, whatever is the system is having energy, that energy is also called as what? Internal energy. Or else the sum of various energies which will be present in the system, that is called internal energy, right? So that is denoted with E, right? Write down. E is a thermodynamic property or not? Internal energy is a thermodynamic property. Remember this one sentence, right? Write down. Absolute value of thermodynamic property. Absolute value of thermodynamic property. Absolute value of thermodynamic property cannot be determined. Then what we have to determine? the change of thermodynamic property only we can determine. Whatever is, not only the internal energy, whatever it, the change of thermodynamic property only we can determine. One system is converted to the another system, what is the difference in their property, that only we have to determine. But so myself is there, what is my internal energy, we cannot determine. If I have done some work, so what will be the change of energy, with the help of that we will get the internal energy difference we will get. Understand? Any thermodynamic property, for example entropy is there. Entropy is, the definition is simple measurement of disorderness of the system. Whatever the system will be there, how much disorderness is there we cannot say, but that will be converted to others. The change in disorderness we have to get easily. Therefore the change of thermodynamic property we can determine. The absolute value or exact value of thermodynamic properties we cannot be determined, right? But the change of thermodynamic property can be determined. So mostly important, notice this is, because so many thermodynamic properties we are going to discuss. No exact value of thermodynamic property cannot be determined. So we can get the change of thermodynamic property only. That's why we have to write delta E, delta S, delta G, delta H, delta A. That is only we have to determine. Delta means change, right? Even D also change, complete change. Dou means partial change, right? So here we have to write capital D. Delta means complete change. Whenever we are using the notation delta means change, right? Delta means change. Then D means also change, complete change. So these are two about complete or else large. Right. Wait ma. So delta can be utilizes for the large change or complete change. D will be utilizes for small change. This small change we may call as infinitesimal change. Infinitesimal change. A small change or infinitesimal change, we have to use D terminology. Delta means complete change or large change, right? So there is a huge change will be there, at the time we have to utilize delta. A small change is there, at the time we have to utilize D only. That's why in case of work, F into DL we have to utilize, right? So what about work? Work is equals to F into DL. DL means a small change, small length, right? So here we don't use delta L, right? DL means that is a infinitesimally small, very small change will be occurs, right? So this is about internal energy. So the exact value we cannot be determined, but we have to determine what? The change of internal energy. So what is meant by change of internal energy? That is delta E. Change of internal energy means delta E, right? Acha, not written, right? So change in internal energy means delta E, right? So this can be explained with the help of first law of thermodynamics, right? So here which can be explained with the help of first law of thermodynamics, right? Write down. It is also known as law of conservation of mass. It is also known as law of conservation of mass, right? Next point, it states that energy neither be created nor destroyed. neither be created nor destroyed, but it can changes from one form to another form. But it can changes from one form to another form. Energy neither be created nor destroyed, but it can changes from one form to another form. But it can changes from one form to another form. That is a law of conservation, even universal law also, right? So another two statements will be there, right? The first statement will be energy of universe remains constant. Energy of universe is remains constant. This is also called first law of thermodynamics. Energy of universe remains constant because we are not creating energy, we are not destroying energy, right? So if we have to create some energy, so therefore that won't possible, right? So but we are not creating energy and destroying energy. That's why energy of universe is always constant or else remains constant. The next statement, energy of an isolated system. Energy of an isolated system remains constant. Three statements of first law of thermodynamics will be there, right? Right. So with the help of this, what is the delta E? Right. Definition. Right on. Right. It is the amount of energy exchange between the system and surroundings at a constant volume. At a constant volume, right? See, so that is the definition of delta E. How we are getting that definition from the first law of thermodynamics means, write down mathematical equation of first law of thermodynamics. What is the mathematical equation of first law of thermodynamics? S. Internal energy is equals to Q plus W. Internal energy is equals to amount of heat absorbed by the system and work done by the system. How much amount of heat is absorbed by the system? From that, how much amount of energy is utilized to do work? The remaining energy is rest in the system. So that energy is known as what? Internal energy. It is the sum of amount of heat is absorbed and work done by the system, right? If it is applied for a small change, therefore we have to written as dE is equals to dQ plus W. But W is equals to what? We know that dE is equals to dQ minus PdV. Why minus PdV? Means work done by the system. Work done by the system. Therefore we have to write dQ is equals to what? We have to write dE plus PdV. dQ is equals to dE plus PdV. So this is the mathematical form of first law of thermodynamics. With the help of this, what we are going to explain the change of internal energy, right? So this is the mathematical form of first law, right? What is the definition of delta E? We mentioned that is at constant volume. The energy exchange, right? The heat is exchanged between, right? So we mentioned energy or heat. Definition: the amount of energy, right? The amount of heat energy. Just you have to add heat energy. There you have to add simple heat, right? The amount of heat energy is exchanged between the system and surroundings at constant volume. That is called internal change in internal energy. Here at constant volume means, what about this dV? dV is 0. So therefore when dV is 0, d is equals to what? dq. Q is means what? Heat energy. This is happened at what? Constant volume, right? Therefore at constant volume dV is equals 0. Therefore Q is equals to d. So this is happened at constant volume. So this is d. d is equals to QV. Means amount of heat is exchanged between system and surroundings at a constant volume. Understand? What is the delta E means? It is a internal energy, right? Some amount of heat is exchanged between the system and surroundings. So how much amount of heat is exchanged between the system and surroundings, that can be considered as its internal energy. That is happened at constant volume. If volume is not constant, there is a work done also will be there. Constant volume means, at constant volume we mentioned that what about work? Work is 0. When work is 0 means whatever is the energy, that is equals to its internal energy. Understand? So I will give one picture here, simple. Right. So we have the system is there. Right. So this system is absorbing some amount of heat energy, and in which some of the energy is utilizes to do work. The remaining rest energy is present in the system, that is known as internal energy. Right. So this is the system is present at constant volume. At constant volume means what about the work? Work is 0. So therefore this internal energy is equals to heat exchange. How much amount of heat is absorbed by the system from the surroundings? There is a heat exchange between them. That is happened at a constant volume. That's why this is the equation QV. Right? So it is also even we have to mention heat energy. This is equals to heat energy at a constant volume. Heat energy at a constant volume. Even we included that. Heat energy at a constant volume. QV is equals to dE is equals to heat energy at constant volume. Whatever is the heat energy is exchanged between the system and surroundings at constant volume, that is equals to its internal energy. Internal energy, right? So just made it this diagram, right? So because when work is 0, whatever is the system is absorbing energy, that will be equals to its internal energy. Therefore this Q is equals to internal energy. That is at a constant volume only work is 0. Therefore we have to mention that heat at constant volume is equals to internal energy. The change of internal energy only we can determine, but exact value we cannot be determine. Right? The exact value we cannot be determine. Only the change we can determine. Right? Next. For ideal gases, so this is a 2 marks question, previous CSR examination. For ideal gases, internal energy is as function of temperature. Internal energy is function of temperature. For ideal gases, E is as function of temperature. Internal energy is as function of temperature. If this internal energy will be differentiated with respect to pressure at a constant temperature, or internal energy is differentiated with respect to volume at a constant temperature, that must be equals to 0. This is the question, 2 marks question in the previous CSR examination. Internal energy is as function of what? Temperature. That is for ideal gases. Ideal gases. So whenever internal energy is differentiated with respect to pressure, we are doing differentiation with respect to pressure. Internal energy is depends on what? Temperature only. No pressure terms are there. Therefore, that becomes constant. Constant differentiation is what? 0. Right? So whenever differentiating with respect to volume, so much meaning is there in the equations, right? So we don't write every time equation in sentences form. We have to understand with the help of equation only, right? Differentiating internal energy with respect to volume. Internal energy is as function of temperature only. Means differentiating with respect to volume means temperature remains constant. The constant differentiation is 0, right? So that is the thing. Okay, right. So whenever heat is observed and heat is evolved, so what will be the change of internal energy we have to see, right? Right. So some reaction will be there. Reactions means reactant by absorbing some amount of heat energy is converted into product. Is it understandable? R and PVS, reactants and products, right? Reactants are plus Q means what? Heat. By absorbing some amount of heat energy, it can be converted into products, right? So for example, so this is at energy. Reactant energy is what? Heat energy is 25 joules, right? How much amount of heat energy is observed? 10. What about the product? 35 joules, right? So therefore, product minus reactants. Product minus reactants. What is meant by its internal energy? Internal energy is a function of change in heat energy. What is the product heat energy? 35. Reactant heat energy 25. 35 minus 25, that is the 10. Therefore delta E will be positive. So even here we have to written as, right, E of products minus E of reactants. Therefore that becomes positive. When delta E is positive, what about that reaction? That reaction is what? Endothermic reaction. Many information we are getting from internal energy. Each and every correlation will be there. So we have started that with heat energy only. How heat will be correlated with the work. How work will be correlated with internal energy. How internal energy is correlated with enthalpy. How enthalpy is correlated with entropy. Like continuation will be there. Once we complete the thermodynamics, at that time only total topic was completed. Otherwise, from day 1 class also we have to utilize at day 13th class. So whenever we are going to discuss one topic in 13th class, at that time what is the day 1 concept is there, that terminology we have to utilize. Continuity will be there, right? If you may involve, definitely you will get, right? So better in good marks, almost 20 to 25 marks you will get from the thermodynamics. So all are concept based only, no numericals, huge numericals are not there. So mostly concept based. As we apply the concept purely on that, definitely you will get that question perfectly, right? Right. Okay. So here delta E is positive means what about that reaction? Endothermic reaction, right? So in some reactions, right, the reactant are converted into products by liberation of heat energy. By liberation of heat energy, right? So therefore reactants energy will be 35 joules, right? So here this will be 20 joules and Q will be 5 joules. Acha, 15 joules. 20 plus 15 joules, right? So what about product minus reactant? 20 minus 35 minus 15. That 15 is equals to Q or not? So this is the internal energy. This internal energy is equals to Q or not? Here see, 35 minus 25 is equals to Q. So that's why delta E is equals to EP minus ER. 35 minus 25, that is 10 joules. That will be Q. Therefore this Q is equals to what? Internal energy. Change in internal energy. Right, here delta E is equals to E of products minus E of reactants. So delta E will be negative. So when delta E will be negative, that reaction will be exothermic reaction. How that internal energy will be correlated with heat energy. So if we understood heat energy properly, so this is very easy. Put constant volume, whatever is the heat will be there, that will be considered as internal energy. Understand? Right. Internal energy is what? Function of? Internal energy is as function of temperature, right? So for isothermal process, what about TT? Isothermal process, change in temperature is 0. So internal energy is also depends on that. Therefore delta E also becomes 0. When delta E is 0 for isothermal process, from first law of thermodynamics, internal energy is 0 means what about Q? Delta E 0 is equals to Q plus W, right? So therefore W is equals to minus Q, right? So each and every interrelation will be there. We have to go through the proper way, so we able to get. But at that time we have to focus on notations, right? So whether positive or negative, when we are choosing positive, when we are choosing negative, and all those things. Okay. So this is about internal energy. It will take some or two classes, because each and every parameter we have to understand in detail only, right? Otherwise even we have to conclude all in one class only, right? Just what is the heat, what is the work, what is the internal energy, what is the enthalpy, how they are related with each other, right? So but in detail, whenever wherever we are utilizing these notations, right? So that we are going to discuss, right? So whenever heat is discussed at constant volume, that is called what? Internal energy. The same heat is considered at constant pressure, that will give enthalpy, that is the H, right? Enthalpy is the H. So what are the definitions and what are the changes of H, and the remaining things will be discussed in the next class. Okay. So please go through every day continuation of the physical class, whether tomorrow class is there or not. If no class is there, day after tomorrow definitely class is there. Just you go through the material, right? So because as you understand these basics, so further we may go little bit higher, right? Okay.